Morning, everybody. How's everyone doing? I hope you had a wonderful Easter break. And welcome back to our daily Algebra 2 videos. Today we're going to be looking at simplifying radicals. So with radicals, okay, we're essentially meaning one type of situation. I guess not really one type of situation, but we're going to have something in these terms, okay? So what these two terms are right here. This x is just our variable, okay? But we're using n as a as a certain term. N is what we call the index. So that's how many, that's a root essentially. That's what we're looking for. We're looking for a third root, fourth root, fifth root, sixth root, square root, things of those nature, just depending on what that n is. A is going to be our power. Now that's just going to play into, I guess, what the index is. We're wanting those two to match up because that's how you end up canceling out that radical. So let's get into it and let's see some examples. So the first one we're going to look at is plus or minus the the square root of 4x squared. So typically what I like to do in these initially is I can work them all together, but if you really don't know what to do yet, break these two things apart, because remember, we can multiply these out and it becomes the same thing. So I'm going to say plus or minus the square root of 4 times plus or minus x to the fourth. Now remember, if there's nothing there for these indexes, these radicals, then that's essentially saying that there's a 2 here. So these are both square roots. So that means I want this power to match these right here. So for 4, I can break that down into saying 2 squared and take the square root of that. For x to the fourth, I can do the same thing. I can break that down and I can say, and how you break it down is you just take whatever this is and you divide it into that term. So 4 divided by 2 is 2. So I can say x squared and take the square root of it. Now, since both of these terms now match up, the square root matches up with the indexes, or with the index matches up with the powers. They cancel out, and we're just left with whatever's inside. Okay, so we should have on this one plus or minus 2x squared. And that's it. Okay. Now we're gonna see, I guess, we're gonna see a few examples of this, so hopefully it'll get a little bit easier for you to understand. Kind of explaining it is kind of feels like it's a little more complicated. When you start working these out and you start understanding them, they become really quick type problems. Just because the way you start just because they're not very difficult. It's just how you have to work them out. Okay. The next one, B, we have the negative of the square root of 4x to the 6 minus 4 all to the eighth power. Now, since this is in parentheses, we cannot break it apart. Okay, so we're actually going to look to still match these terms. So since the index is still 2, I want the indexes to match up. So I'm actually going to break down this one here. So I'm going to take 8, and I'm going to divide by 2, and we end up getting 4. So we end up having 4x to the 6th minus 4 to the 4th power. That's all squared. And we can't forget about negative square root. Now, since these indexes and the powers match up, they cancel out. And we're left with whatever's inside and the x. So we'll have negative 4x to the 6th minus 4 all to the 4th power. Alright, C. 32 x to the 5th, y to the 15th. And this is actually going to be a fifth root. So for this one, we have a few options to work. Okay, if you don't know what the fifth root 32 is, we can break it apart. And that's how we're going to do it initially. We're going to break all these down. So we're going to have 32 fifth root times fifth root of x to the 5th times fifth root of y to the 15th. Now we can break them down. So 32 we can break down into 4 times 8, 2 and 2, 2 and 4, 2 and 2. Now remember back to the last time when I was talking about this, whenever you have whatever your index is the amount of times you want something to be the same. It's what you're looking for the in common. So since this is a 5, I'm looking for a number that repeats itself 5 times. And we actually have it here. 1, 2, 3, 4, 5. Okay? So we know our number. So this one could actually break down into 2 to the fifth root times 5 divided by 5 is 1. So x all to the fifth root, fifth power, and then times 15 divided by 5 gives us y cubed to the fifth power. We're taking the fifth root. So once we've done all that, we know all our index cancels out with our powers. So we're left with 2x y cubed. Okay. And now we'll look at D. The square root of negative 4x squared minus 4. Now remember, you cannot take the square root of a negative number. So this is actually going to be an imaginary number. So the first thing we do, once again, is we break it apart. Negative 4 square root times square root of x squared times square root of y to the fourth. So I want to break this apart. So I know this negative comes outside. In a second. I didn't switch earlier, but let's continue. And so this negative comes outside and leaves us with I. And it's also plus or minus. Okay? So it's plus or minus I when you pull it out. And we have the square root of 4 times. This is going to be, so since these are all 2's once again, we have x 1 squared, or 2 divided by 2 is 1, and it's all squared. And the same thing with y to the fourth. 4 divided by 2 is 2, and we're all squared. Now, we can finish this problem off. The square root of 4 is 2, so we should have 2 plus or minus, plus or minus 2i. These two cancel out, which leaves us with just x. Square root of 2 and 2 cancel out over here, so we're left with y squared. So we're left with plus or minus 2ix y squared as our answer. So now we're going to look at a little something. We're going to look at the same thing, but it's some scenario you always have to think about whenever you're working these problems out. So if both the index and the power are even numbers, and the result of, so the answer you get is an odd root. The answer must be positive, so we use absolute values. So what that's essentially saying, if the index and the power are even, okay, and when we take this, we know that 8 divided by 8 gives us 1, so this would essentially be x to the 8th power, 8th root. These two things would cancel, and they leave us with x. Since the index for x is essentially an odd number because it's 1, in order for this to be correct here, I have to use absolute values. So that would be my answer. Okay? So anytime you're working these problems, you always have to look for that scenario. So for f, we do the same thing. So I'm going to break it apart. 64, I'm taking the 6th root times x squared minus 3, the 18th, the 6th root. So we can break down 64. I'm not going to break it down because that's a little much. Okay, remember, majority of these times they're always going to be smaller numbers. So for 64, the 6th root of it is 2. So when I break this down, it would be 6th root of 2 to the 6th times, and since these are in parentheses, you would just break down the exponent. 6 divided by 8, or 18 divided by 6 is 3. So we would have x squared minus 3 cubed the 6th power, taking the 6th root. So these would cancel, and you're left with 2. And now, whole numbers, we don't use absolute value because it's positive by itself. A variable may not be positive or negative because it could be positive or negative numbers, so we have to make sure and ensure that. So for a variable, you just leave it on the outside. It doesn't have to be inside absolute value. But since this one, we have an even index and even root, and the answer they give us is odd, okay, these will have to be in an absolute value. So x squared minus 3 cubed, and we're absolute value. And that'll be the answer, okay? The whole numbers can be outside of it, even though our index is, or our power 4 is technically 1. Okay, that's it. I hope you all have a good day, guys. That's it for today's lesson, and peace.